In this mechanics video, a uniform rod of mass 6 kilograms is on the verge of slipping on a rough horizontal surface with coefficient of friction of 2/5, with a mass of 2 kilograms placed at a distance x meters from the ground along its length of 1.2 meters. The tasks are to calculate A, x, B, the tension in the string, and C, the reaction force of the ground on the rod. First thing to do is to put all the forces and components of forces and various angles on the diagram, which will allow me to calculate A, B and C. First thing to do is to put the weight of the uniform rod, which will be 6G, which will act vertically down at the centre of the rod, as shown by the 6G newtons at a distance of 0.6 meters along the rod. The 2 kilogram mass will have a weight of 2G newtons, and that will act vertically downwards at a distance of x meters from the foot of the rod. Because the rod is on the verge of slipping, it will be slipping horizontally to the left, so the frictional force will oppose that motion horizontally to the right and is denoted by F. There will also be a normal reaction of the rough ground on the uniform rod acting vertically upwards, shown as force R. There will also be a tension in the string denoted by T newtons. Now, to find the angle that the tension makes, the tension in the string makes with the horizontal, I have shown the green angle as being 30 degrees. This is alternate angle with the angle that the rod makes with the horizontal. So the angle that the string makes to the horizontal will be 75 degrees minus 30 degrees equals 45 degrees as shown. Now, resolving the tension in the string horizontally will give T cos 45 acting to the left and T sine 45 acting vertically upwards. I have also denoted that the point at which the rod meets the rough horizontal ground as point A. So for part A, I have now taken moments about the point A. Now a moment is force times perpendicular distance, so I put on the red dashed line to represent the perpendicular distance that the string makes with the point A. Now that red dashed line is the side opposite the angle of 75 degrees, and the hypotenuse is the length of the rod, which is 1.2 meters. So the red dashed line is 1.2 sine 75 degrees. Now the tension in the string is going to try and produce an anti-clockwise moment, and the two weights are both trying to produce clockwise moments as shown by the orange arrows. So taking moments about A, we have a anti-clockwise moment of T times 1.2 sine 75 degrees. And that's going to be balanced by the two clockwise moments, which will be 2G times x cos 30. Now the x cos 30 is this distance shown in blue here, because I want the perpendicular distance that the 2G weight makes with the position A, or point A, which is that horizontal distance there, which is the adjacent, and the hypotenuse is x meters. So that horizontal distance is x cos 30 degrees. And similarly, I need to add the moment that the 6G weight produces, which is 6G times that horizontal distance, which will be 0.6 cos 30 degrees. So making T the subject of that formula, what I have done is I have divided each of the two terms on the right hand side by 1.2 sine 75 degrees. And this gives the tension in the string in terms of x, as shown by equation 1, 14.64x plus 26.36. Now resolving horizontally, the horizontal force acting to the right is F, the frictional force, and that must be balanced by the horizontal component of the tension acting horizontally to the left, which is T cos 45. So multiplying the right hand side of equation 1 by cos 45 gives the frictional force in terms of x as 10.35x plus 18.64, and I've denoted that as equation 2. Now, since the frictional force F equals mu r, where mu is the coefficient of friction, rearranging this equation gives the normal reaction R as equal to the frictional force divided by the coefficient of friction. So this is in fact the right hand side of equation 2 divided by the coefficient of friction 2/5, which gives the normal reaction in terms of x as 25.875x plus 46.6, and I have denoted this as equation 3. Now resolving vertically, the forces acting vertically upwards are R, so R plus the vertical component of the tension, which is T sine 45, must be balanced by the sum of the two weights acting vertically downwards, which will give 8G. Now substituting R from equation 3 and using T from equation 1 and substituting into that equation, and now collecting the x's on the left hand side and the numbers on the right hand side, gives 36.23x equal to 13.16. So therefore x equals 0.363. So the maximum distance along that uniform rod that the 2 kilogram mass can actually be before the rod actually slips is 0.363 meters. Now for part B, the tension in the string needs to be calculated. So using equation 1 and substituting x as 0.363 gives the tension in the string as 31.7 newtons to 3 significant figures. And for part C, firstly, I have found F by using equation 2 and putting x as 0.363 into it. So the frictional force equals 22.40 newtons, and using equation 3 similarly, R, the normal reaction, equals 55.99 newtons. Now drawing a right angle triangle force diagram, I have shown this, and RF is the reaction force. So the reaction force using Pythagoras' theorem will be the square root of the frictional force squared plus the normal reaction squared to give a reaction at the ground on the rod of 60.3 newtons to 3 significant figures. Now because this is a force, it's a vector quantity, the angle that it makes to the horizontal or the vertical will need to also be worked out. So I have put in theta, which is the angle that the reaction force makes with the horizontal. So the angle theta equals inverse tan, the opposite 55.99 over the adjacent 22.40 to give an angle to the horizontal of 68.2 degrees, and I have also stated to the horizontal. This is another one of my mechanics videos that I have created recently. Again, I hope that you have found it both interesting and informative.